Did you know high frequency transformer-less inverter has way more advantage than low frequency transformer-based inverter? Hello everyone, my name is Bashir from Interdem. So we'll be talking about the future of this inverter. Actually, we'll be talking about the future of both transformer-less high frequency and transformer-based inverter. So let's look at the features of both transformer-based and transformer-less inverter. So they both have their advantages and disadvantages. The first one is pure sine wave. The inverters are pure sine wave. Configurable input voltage, configurable battery charging current, and configurable solar charge priority. Compatible with mains and generator. Overload, over temperature, short circuit protection, smart battery charger design, cold start function. So let's talk about the advantage of high frequency inverter over low frequency. The first one we'll pick is configurable parameters. So what do we mean by configurable parameters? It has input voltage configuration, which means you can select the input voltage you want. Charging current selection, which means you can select your charging current from as low as maybe 10 amps to 100 amps or whatever current you want to choose. Unlike low frequency transformer based inverter, which comes with default and is unchangeable. AC solar charge priority. This is for people that have prepaid meter. So if you have the sun and you have your AC, your NEPA, instead of going to turn off your prepaid meter, you can just simply prioritize the charging current of your inverter to pick solar. It is when there is no solar that it will go and pick NEPA. So as long as there is sun, it will leave your NEPA alone. It will leave your unit, your prepaid alone until there is no sun. Then if there is still NEPA, it is going to pick NEPA after when there is no sun. So the second advantage is high charging current. And what does high charging current mean? High charging current, the advantage of high charging current is that these inverters, they can charge with as high as 100 amps, even for the small, or let's say the small capacity of inverters. Like this one now, this is a 4.2 kilowatts and it can charge as high as 100 amps. Meanwhile, our low frequency inverter, the transformer base, can charge the normal charging current they have is 30 amps or 50 amps maximum. That's even for like 10 kVA. While this one is having about 100 amps for just 4.2, even the 3.6. So, and what's the advantage of having a high charging? If you have two batteries, like this one now, this one uses two batteries. Now, if you want to add to the battery, it gives you the opportunity or the advantage to increase charging current, because the default charging current that comes with is 30 amps. Now, that 30 amps is to charge two pieces of battery. Now, when you add two pieces more to the battery, definitely you have to increase the charging current, which means when your battery is now 4, your charging current should be 60. When your battery is 6, your charging current should be 90. So you can use about 6 pieces of battery with this, and this inverter will still be able to charge it conveniently and to charge it full. So the number 3 advantage is that it has high PV input. And what I mean by high PV input is that the inbuilt charge controller inside these inverters, these high frequency inverters, they are as high as the capacity of the inverter. So let's say this one now is 4.2 kilowatts. The inbuilt charge controller inside this can take up to 4.2 kilowatt solar panel, or even more than. I think this one is, the inverter is 4.2 kilowatts and it can take as high as 6.2 kilowatts of solar panel, which means even our normal external charge controller, an average is like 2000 watt, 3200 for 60 amps charge controller. But this one is packaged with a 4.2 or 6.2 kilowatts of charge controller, which is about twice of an external charge controller. So this is a win-win. So another advantage is high and wide PV input range, which is this inverter has the capacity of taking wide input voltage range from solar panel from as low as 90 volts to as high as 450 volts. Now, what does that mean? That gives you the advantage of using like a low gauge of cable to draw each string. Let's assume I want to use 2 strings for this inverter, a 16 pieces of solar panel, 300 watts. Then I can connect eight pieces in series. So each of that 8 pieces I can use as low as 4 mm cable to draw those strings individually, making it 4 cables. And it will be totally okay. In fact, in the manual it's recommended 4 mm. You can use 4 mm to draw 8 pieces of panel in series for each string. High voltage that it is gives you the advantage to be able to use lower gauge of cable. But if it is a low voltage, you have to be doing a parallel connection, which when you are moving currents, your gauge of cable has to be thicker. But in this case, it's not. So that's another advantage. Now, charging frequency too is something to talk about. In our low frequency inverter, charging frequency, we all know when the frequency of your supply is not within the range of 49 Hz to like 51 Hz. Let's say you are using a generator. Even if your voltage is 220, the inverter will not charge. It will reject it. Let's say your frequency is around 49 to like 51 Hz. But in this case, for high frequency inverter, it's different. High frequency can take as low as 40 Hz to as high as 55 to like 60 Hz, and it will still charge. As long as your voltage is within the specified range that you set it to, it will charge fine. So if you are using a generator, the frequency of the generator is not balanced. When you are using high frequency inverter, you have no worries. Another sweet thing I really like about high frequency inverter is the way they changing over to solar. You see, just the way inverter change over to NEPA whenever there is lights, high frequency inverter does that too, but it has an additional one that it does again. When there is sun, this inverter changes from battery to sun. As long as the capacity or what you are generating from the sun is enough to power what you are using inside the house, it will change your load entirely from inverting or from battery to change over to solar, as if it's changing to NEPA. So that in turn gives these inverters an advantage, which makes it be able to work without battery. So when you connect it to solar enough, that's why it's high voltage. So as long as your voltage is above 220, like you are generating like 250 plus about 300 volts, it will be convenient for it to change you to solar, just as if it's changing to NEPA, and you need to leave your battery alone. So that's another advantage of high frequencies. We have another one, which is two load outputs. What two load output? Okay, actually on this particular brand, which is Solfit, they have that feature. It's not all high frequency that has that feature, but this one has it, and most high frequency has it. So two load output, as this one is 4.2 kilowatts, it has an additional extra two load output, which is like I think 1,200. We check it, 1,200. Maximum second, 1,400 watts. So it's an addition. If we want to add 1,400 watts to 4.2 kilowatts, that will be giving us 5 point or about 6 kilowatts, I think. So sometimes you can just connect your the two load output to maybe like lightings and all. Then the main load, which is 4.2, you connect to the heavy loads and all. Now the last one on my list is surge power. High frequency, especially this brand, it has surge power of ×2 of the rated capacity of the inverter, which is saying, as this one is 4.2 kilowatts, the surge power is within 5 seconds. So that means if I mistakenly plug a load of 7 kilowatts, as long as it's within 5 seconds, this machine is still capable of protecting itself. Now, so many people will be like, transformerless inverter, they cannot handle load. We are going to prove that, but trust me, transformerless inverter can even handle more load than transformer-based inverter. The technology of transformerless inverter has increased so much, unlike those days that they first started. Now let's go to advantages of low frequency over high frequency. And number one we'll talk about is longevity. People often say high frequency inverter does not have long lifespan. Well, maybe as at 2015, you can see that. But right now, that's not true. High frequency inverter has a very, very long lifespan. We have high frequency inverters that's I think way back since from 2016 or 2017, they've been using it, and those inverter has never visited service center. So from that time till now, it's about 8 years. So an inverter I not visit service center about 8 years. I think that's enough for a long lifespan. The issue with transformerless inverter is that the necessary precautions that installer are supposed to take, they don't take it. There are protection that is required for this inverter to have a very long lifespan. If you do not protect these inverters with those protections, it will not last long. But once you do that, trust me, this inverter has a very, very long lifespan. Now, another advantage of low frequency transformer based inverter over high frequency is that the durability. What is durability? Durability in terms of withstanding overload, withstanding high volt inputs, standing short circuit, and all. Yeah, those are the advantages. But let me tell you, inverter is still inverter. Inverter is electronics, and electronics, no matter how good it is made, it can still spoil. The low frequency inverter we have, high voltage used to spoil them, short circuit spoil low frequency transformer based inverter. Over voltage input spoils low frequency transformer. We have them so many. Just that if this high frequency inverter can get spoiled within 1 month due to over voltage, a low frequency transformer based inverter can use up to like 6 or 1 year before it will spoil. But the fact is, they are both going to spoil. Low frequency will spoil, high frequency will spoil if it's seen over voltage. The difference is that this one will spoil quickly, low frequency will take more time. But since you know that they are going to spoil, both of them, if you are using over voltage, you are exposed to over voltage. Why not protect yourself from over voltage? You can just protect that so that both the low frequency and the high frequency, none of them will get damaged by over voltage. So it's as simple as that. Short circuit can spoil high frequency, and at the same time can spoil low frequency. But then they can spoil faster than each other. But since that thing can still spoil both inverter, then just protect yourself from getting affected by over voltage, by short circuit, by thunder arrestor. And once you do that, you won't have to be dealing with the fact that an inverter got spoiled due to over voltage or over current and all. So those advantages, I don't really see it as an advantage, you ask me. So let's look at the common mistakes most of us installers used to do when dealing with high frequency inverters. Now, unlike low frequency inverters, high frequency inverter, whenever you are installing them, it is a programmable inverter, and once you finish installing them, you have to do those necessary programming, which is most things that people used to leave it. And when you do that, the inverter cannot function to its full capacity. You have to set those parameters for the inverter to perform up to its maybe like 5% efficiency for you to get up to that percentage of efficiency. So what are the parameters that need to be set? Number one is output source priority. You need to set your output source priority regularly. All of them used to have, I think, about 3 to 4 priority. One of them is solar priority. Another one is utility priority. The first priority, the utility first. So if you pick utility first, that means you are saying utilities, your NEPA should provide power to your load as first priority. So when there is no NEPA, it's going to go to solar. When there is no solar, it's going to go to battery. When you pick solar first, solar priority, it's going to take, when there is sun and there is NEPA, it's going to take solar as priority. It is when the sun is not enough anymore, it will now check if there is NEPA light, it will now switch to NEPA light and supply to your house. Then if there is no NEPA light again, that means it will now go to battery. And the last priority on this one is the solar and battery priority. This one does not take into consideration NEPA at all. It will check if there is solar, it's going to be using solar. And once there is no solar, it's going to switch to battery and be converting your battery. It is when the battery is now low that it's now going to consider to switch to electricity, which is your NEPA. So that's that about the priorities. You need to set your priorities based on end users' demand. End user might tell you, I have sun now, and I have sun that is NEPA, but the sun is there. Why should I be wasting it? That's the mode I normally use though. Solar first. When there is sun, why should I let my clients be wasting units? So you should keep his units. If there is need for that later, when there is no sun or the battery is low, then you can use it. The second one is maximum charging current. You need to set your maximum charging current. And the maximum charging current is as a result of utility charging current and solar charging current. This one has about 140 amps maximum charging current. So utility alone can charge with 100 amps. Then if you add solar to it 40 amps, then that 140. The utility might not be charging with up to 40 amps. Maybe just set it to like 50 amps. Then solar will be charging with like 60 amps. But just so that the maximum charging current is 140. That's for this particular one in front of me. Another one is input voltage range. You need to set your input voltage range. Like, okay, you want your input voltage to be from range of 178 volt AC to like 265 volt AC. Okay, you want it to have higher. Okay, just to be safe, you set it to 200 volt AC to 265 volts. You need to set that one. Another one is utility charging current. So the utility charging current is different from maximum charging current. The utility charging current now is just your charging current from mains, which is NEPA source. Your battery type, you need to set your battery type. It's very, very, very important to set your battery type. If you connect your inverter to a lithium battery, because this inverter has communication with lithium, connect your inverter to a lithium battery, and you leave the battery type to AGM or jet battery or flooded battery, is definitely going to misbehave, because the low battery cutoff, the battery, the floating, the float charge, the bulk charge, everything messed up. So you need to set your battery type setting. Another one is charging source priority. So the charging source priority is a little bit different from output source priority. Charging source priority is just saying what mode should I use to charge your battery. Do you want to use solar to charge your battery? Do you want to use utility to charge your battery? So those are the priority. Then you need to set your bulk charging. If you are using a tubular battery like this one now that is 24 volts, your tubular battery, for it to be fully charged, 14.4 per battery, 14.4, 14.5 per battery, which the two of them should be around 29 point something. So if you do not set your bulk charging, your battery will just stop at 28. And at 28, your tubular battery, your 24 volt system is not fully charged. It has to get to like 29 or 29.5 for it to be fully charged and be floating. So you need to set your bulk charging, you need to set your float charging, and you need to set your low battery cutoff. It's very, very important, because this inverter, they can drain your battery to wherever you want it to be. If you leave the settings at default, it will affect the battery. It will also affect the inverter. So you can't leave the settings at default. That's what low frequency does. Most of low frequency, we use default setting. There are some that are programmed, but very rare. So you need to take these things into consideration and make sure you set it. And once you set it, you'll be surprised of the percentage of efficiency this can give you over a low frequency inverter. Okay, so there you have it. If anybody tells you that low frequency is better than high frequency, I have successfully explained everything. And for those of you that like to call for me, if you have not used high frequency inverter, if you are not familiar with high frequency inverter and get your facts right, please don't come to me with a blind argument. So the last one is everything we've said about this inverter, we are going to show it in part 2. Maybe everything we've been saying, they are just gimmick. Maybe it's not real. It cannot charge with 100 amps. It doesn't have a power up to that, up to what we've said. I'm going to show you the installation of this, and the load. Can it handle load, or it cannot handle load? Just like everyone used to say that high frequency cannot handle load. So we'll see that in our next video. If you are new to the channel, consider to subscribe and give us a thumbs up. Thank you.